What's going on, my dudes? This is Mr. Gardner, and this is Math Time with Mr. G. We're going to talk about transformation of exponential functions. So that just means I make a function, and how much does it move when I add variables to it. We're going to call it vertex form, and I'm putting that in quotes because there is no vertex with an exponential function. And a vertex means the very, very bottom. Well, this line is going to keep going. Well, if it's not the very bottom, it's going to be the very top. Well, that's just going to keep going. So there is no vertex in exponential form, but this vertex form is very, very similar to our absolute value one. So this was our form when we had absolute value, and it's very, very similar to that. And you can see it's very, very similar in exponential form, but I want you to know that it is not a vertex. It is saying take our original graph and we're going to move it. Anytime we're given an exponential function, we have to compare it to the parent graph. And because there isn't a true parent graph in exponential graphs, because if I said, hey, y equals 1x, that's just going to be a straight line going across. We always compare it to the number in the a term. So my parent graph for this function is y equals 2 to the power of x. So that means that my y-intercept would be at 1, and then up 2 over 1, going like that. My new one of adding plus 3 means I would go up 3, and then have a parallel graph to that. Here, my parent graph would be y equals negative 3 to the power of x. This minus 1 would mean to go down 1. And then plus 4 is opposite way, I think. So it's going to go over 4. And there is, again, in quotes, vertex. And I'm going to go down 3 over 1. So down 1, 2, 3 over 1. And it's going to look something like that. So that is my new graph. My original would have been parallel like that. If you guys have any other questions, hit me up in the comment section. But other than that, be kind to each other, ask lots of questions, and think deeply.